Alright, let's take a look at problem 2 from homework 8. So this was a problem regarding this error function, f of x, which is 2 over square root pi integral from 0 to x, e to the negative t squared dt. So we cannot find an antiderivative of e to the negative t squared, so therefore we can't really simplify this integral function any further than we already have. So that means that we're going to have to work with this function as an integral. And so let's see how we can do that. So the first problem asks us, what is the domain of this function? Well, we just have to ask, what are the possible values of x that we can plug in? Well, there's really no problem with any x values. If we plug in a positive x value, we're just integrating up to that point, so we can integrate out to infinity. Or if we plug in a negative x value, you can switch the domain or the upper and lower bounds of the integral and pull a minus sign out. So you just get the same exact thing except for with a minus sign. So the domain is negative infinity to infinity. The next part of the question asks us to show that f of x is an increasing function. So to do that, all we have to do is to show that f prime is always positive. So f prime of x is equal to the derivative of 2 over square root pi integral 0 to x e to the negative t squared dt. And if we use ftc2, then we'll get 2 over square root pi e to the negative x squared. So this is by the second fundamental theorem of calculus. And this thing here is always greater than 0. And if the derivative is positive, this means f is increasing. Okay, so then part C asks us to show that f of x is an odd function. Well, let's take a look at f of negative x. This is equal to 2 over square root pi integral from 0 up to negative x e to the negative t squared dt, which if we flip the bounds is the same as negative integral from negative x to 0 e to the negative t squared dt. But now, if we take a look at the function e to the negative t squared, it looks something like this. So e to the negative x squared is even. So what this means is that the integral from negative x to 0 e to the negative t squared dt is the same as integrating from 0 up to x e to the negative t squared dt, right? Because the area over here to the left of the x-axis is symmetric with the area over on the right. So that means that f of negative x is equal to negative 2 over square root pi integral from negative x to 0 e to the negative t squared dt, just by carrying down what we had before. And this thing is equal to, let's see, right, if we use this equality here, then we'll get negative 2 over square root pi integral 0 to x e to the negative t squared dt, and this is just negative f of x. So this means that f is an odd function. Okay, so the next part of the problem asks us to estimate the limit as x goes to infinity f of x. So we can just do this using a computer. So we'll see that limit as x goes to infinity f of x is equal to 1. And since f is odd, the limit as x goes to negative infinity f of x is equal to negative 1. because we know that if we reverse the sign of x on the inside, then all we do is multiply the function value by a negative sign. So that means that whatever the function of values of f are as we go to infinity, the values as we go to negative infinity are negated, so they become negative instead of positive. And then the last part, the range of f of x is -1 to 1. So we know this because f of x is an increasing function by part b, so it always has to be going upwards. And as x goes to negative infinity, it levels off at -1, so it's not going to be able to go below that. And as x goes to positive infinity, it goes to +1, so it can never go above that. So that means that we always have to have values between -1 and 1 for this function. So it ends up turning out that f of x does something sort of like this.